Hi guys, this is Saurav here and welcome to the Vedantu VOS channel. This session is particularly helpful for people who are preparing for IOQC or NSEC or InChO as well as JEE and NEET. This is in continuation of something which we have already done. We have already covered the first part of ionic equilibrium in which we talked about buffers, and we had also learnt about what is buffer capacity. Today's session is about a very misunderstood topic which is known as hydrolysis. Hydrolysis एक काफ़ी beautiful सा topic है और इस topic को समझने के लिए हमें बहुत ज़्यादा मेहनत करने की ज़रूरत नहीं है, but just we need to keep our eyes and ears open. So let's start today's session and let's try and understand कि what hydrolysis is all about. Salt hydrolysis. Hydrolysis को हम salt hydrolysis जैसा पढ़ते हैं, and to start with hydrolysis, we need to first understand what actually happens when a salt is present in water. So, when you take a salt and add it to water, the cation and anion get removed from the salt and they become free in the medium. Okay, so salt dissolves in water to produce a cation and an anion, and the cation has the potential to act as an acid and the anion to act as a base. They can exist as hydrated ions with water to reform acids and bases, and this reaction of cation and anion as an acid or a base is known as hydrolysis. चलिए 3 पॉइंट हमारे पास आ गए हैं, हम इसको समझने की कोशिश करते हैं कि ये होता क्या है. So let's say we start with an example of sodium chloride. सोडियम क्लोराइड को जब पानी में ऐड करते हो, यू गेट Na प्लस आयन एंड Cl माइनस आयन. ठीक है, अब Na प्लस आयन एंड Cl माइनस आयन जो प्रोड्यूस हुए हैं वाटर में, ये वाटर में तो खाली बैठे नहीं रहेंगे. व्हाट दे विल डू इज दे विल Na प्लस विल इंटरैक्ट विद द नेगेटिव एंड ऑफ द डाइपोल, मतलब ऑक्सीजन के साथ इंटरैक्ट करेगा. If you all know, oxygen carries a del negative charge and hydrogen carries a del positive. तो इस तरह से सोडियम को सराउंड किया जाएगा. From all directions, sodium will be surrounded. And similarly, chloride will be surrounded in all directions by water molecules. But chloride will interact with the positive end of the dipole. ठीक है, it will interact with the positive end of the dipole. अब हिसाब ये बनता है कि ये प्रोसेस को हम बोलते क्या है. This process is known as hydration. Okay, इसको आप सॉल्वेशन के नाम से भी जानते हो. अगर कोई और अगर मैंने वाटर लिया है तो मैं इसको हाइड्रेशन बोलूंगा. सॉल्वेशन विल बी अम्ब्रेला टर्म. हाइड्रेशन would be utilized as a term to reflect the fact that इनको पानी में dissolve किया गया है. So if water molecules are surrounding it, I'll call it hydration. ये चीज दूसरे किसी salt के साथ भी हो सकती है. Let's say you take sodium acetate, so CH3COO minus is produced and Na plus is produced. So this over here also similar situation can take place. So acetate is written as ACO minus and it will be surrounded on all sides by the positive end of the dipole. Okay, positive end of the dipole. And Na plus will be surrounded by water molecule exactly in this fashion. Now the point is that कि इसमें अभी तो मैं इसको हाइड्रेशन ही बोल रहा हूं. आई एम अगेन कॉलिंग दिस हाइड्रेशन. बट व्हाट इज हाइड्रोलिसिस? हाइड्रोलिसिस होगी कब? सो लेट्स ट्राई एंड अंडरस्टैंड दिस. मैंने NaCl को वाटर में जब ऐड किया था तो मेरे पास Na प्लस एंड Cl माइनस दोनों मीडियम में आए थे. ये वाटर के साथ इंटरैक्ट करके दे क्रिएटेड hydrated species, hydrated Na plus and hydrated Cl minus. However, if I take CH3COO Na, यहाँ पे कुछ डिफरेंट भी होता है. It produces CH3CO minus and Na plus. और ये जो CH3CO minus है ना, ये सिर्फ हाइड्रेटेड नहीं रहता है. CH3CO minus can undergo reaction with H2O and ends up forming CH3COH and gives out OH minus. ये जो सोडियम है Na plus आयन, ये वाटर की प्रेजेंस में सिर्फ ये हाइड्रेटेड ऐसा रहता है, हाइड्रेटेड Na plus के फॉर्म में रहेगा. सो व्हाई इट इज डिफरेंट ओवर हियर? यहां पे ये डिफरेंस क्यों है? इसको समझने के लिए वी नीड टू चेक कि ये जो प्रोसेस है, व्हाट इज द इक्विलिब्रियम कांस्टेंट फॉर दिस, और व्हाई द फर्स्ट रिएक्शन इज ऑकरिंग, व्हाई द सेकंड रिएक्शन इज नॉट ऑकरिंग. सो मैं ऐसा करता हूं कि मान लो कि इफ आई टेक Na प्लस आयन और इसको मैं वाटर के साथ रिएक्शन कराता हूं, व्हाट वुड बी द आउटकम? हाइपोथेटिकल आउटकम मैं लिखता हूं NaOH प्लस H प्लस. एंड इफ आई राइट द हाइड्रोलिसिस, सो दिस प्रोसेस इज नोन एज हाइड्रोलिसिस. वाटर के साथ रिएक्शन करके एसिडिक मीडियम या फिर बेसिक मीडियम क्रिएट करना इज नोन एज हाइड्रोलिसिस. एसिडिक मीडियम क्रिएट करने का मतलब दैट H प्लस इज बीइंग प्रोड्यूस्ड. The meaning of creating a basic medium is that OH minus is produced. Okay, so जैसे कि CH3CO minus is producing a basic medium, producing a solution whose pH will be more than 7. So let's try and understand, let's represent this with an equilibrium sign. Okay, and let's write this as hydrolysis constant. This hydrolysis constant will be written as NaOH times H plus divided by H2O times Na plus. अब मैं क्या करता हूं कि I multiply and divide by OH minus. When I do this, the equation can be split into two parts. NaOH, Na plus H2O एक part हो गया, and the other part becomes H plus OH minus upon H2O. क्या मैं इस part को, this part, can I write this thing as Kw, and this part, doesn't it look like the reverse of dissociation of NaOH? अगर NaOH को dissociate किया जाए तो it will form Na plus plus OH minus. So this reaction looks like the reverse of dissociation of NaOH. So therefore reverse क्या हो जाएगा? If forward is written as Kb because base का dissociation है, तो the reverse will be Kw upon Kb. Now Kw की वैल्यू कितनी होती है? 10 raised to minus 14. और Kb की वैल्यू कितनी होगी? It's a very strong base, so I am hypothetically keeping it between 10 raised to minus 5 to 10 raised to minus 10. चलो मैं 10 raised to minus 5 ले लेता हूँ. Not 10 raised to minus 5, 10 raised to 5 to 10 raised to 10, 10 raised to 5 ले लेता हूँ. तो ये वैल्यू कितनी बन रही है? 10 raised to minus 19. ठीक है? This value becomes equal to 10 raised to minus 19. अब इसको समझने के लिए एक और चीज हमें चाहिए. So 10 raised to minus 19. ठीक है? ये हो गया Na plus के लिए. Let's write a similar sequence for acetate. CH3COO minus plus H2O. अगर मैंने इसको लिखा, I'll be getting CH3COOH plus OH minus. अब इसके लिए KH का एक्सप्रेशन ये हो जाएगा CH3COH. Numerator would have OH minus, denominator would have CH3CO minus H2O. I hope you have understood this part, that just a moment. Okay, where did this go? Yeah, sorry. Okay, so unfortunately erasing this is a challenge. So I'm taking this, I'm writing this over here. ये कितना हो जाएगा? What I do is I take KH. So I multiply this with H plus and divide this with H plus. I would be able to split this whole equation into two parts. I'll be splitting this into CH3COH divided by CH3CO minus times H plus, and H plus OH minus divided by H2O. अब इसको लिखा कैसे जाएगा? I'll write the expression. This expression will be written like KW, and this will be written as 1 upon Ka. KW value is 10 raised to minus 14, और ये जो value है Ka of acetic acid turns out to be 10 raised to minus 5. This gives me a result of 10 raised to minus 9, which means this value is too large as compared to this one. देख लो, इन दोनों values को compare कर लिया हमने. If I take sodium acetate, I am getting the hydrolysis constant value for sodium acetate in the order of 10 raised to minus, for acetate ion in the order of 10 raised to minus 9, while for sodium ion it comes as to be 10 raised to minus 19. So if I have some knowledge of equilibrium, can I say that KH for CH3CO minus is way more favorable than KH of Na plus? इससे हमें conclusion क्या मिलता है? The conclusion that we get from here is this, that if ion comes from strong electrolyte, then it will only undergo hydration. But if ion comes from weak electrolyte, then उसकी hydrolysis होगी. Okay, then it will undergo hydrolysis. समझ में आया? ये जो entity है sodium acetate में, this part, this is coming from a weak acid. Weak acid से ये आता है, और ये जो भाई साहब हैं ये आते हैं एक strong base से. Sodium chloride में Na plus comes from NaOH, which is a strong electrolyte, and Cl comes from HCl. So both of them are strong electrolytes. Therefore Na plus and Cl minus, when they are produced in water, they will only undergo hydration. They will not undergo hydrolysis. Is that clear? I hope this is understood. Let's move on to the next part. So अब हम अगर कुछ salts ले लें, then we will be able to identify कि इनमें कौन सा ion hydration में सिर्फ participate करेगा and which will participate in hydrolysis. So let's start with NaCl, Na2SO4, KCl, KNO3, CH3COO whole twice Ca NH4Cl CH3CO NH4. ठीक है, अब इनमें से जो आयॉन्स हमें मिलेंगे, फर्स्ट लेट्स राइट देम. The ions that we would obtain from each of these species are Na plus, Cl minus, Na plus and SO4 2 minus. I'm not writing the number of cations that will be produced, I'm writing the nature of cation that will be produced. Cl minus, K plus, NO3 minus. This will give CH3COO minus and Ca2 plus. This will give NH4 plus Cl minus. This will give acetate. You have to understand कि ये जो salts हमें मिल रहे हैं, ये salts एक न्यूट्रलाइजेशन रिएक्शन के एंड पे मिलते हैं. हमेशा याद रखो, salt hydrolysis is applied at the equivalence point. Okay, मतलब only salt is present. Now इस salt को बनाने के लिए can I say to create this salt Na plus must have come from NaOH and CHCl minus must have come from HCl. It must have come from a strong base, this must have come from a strong acid. So what would happen to cation and anion? अगर मैं यहाँ पे टेबल बना के लिख दूं, okay, let's make a table. So cation, anion, cation and anion behavior, what will happen? So can I say for the very first one, NaCl के केस में cation का सिर्फ हाइड्रेशन होगा and anion will also undergo hydration. अगर सिर्फ हाइड्रेशन होता है ना, तो सॉल्यूशन की पीएच चेंज नहीं करती है. मतलब वाटर ने बस किसी चीज को सराउंड कर लिया. व्हाई वुड द पीएच चेंज? नो न्यू H plus is produced, no new OH minus is produced. So pH of the solution, that means pH जो अब आपने NaCl का सॉल्यूशन लिया है उसका pH हमें अगर बताना है, then what we will say is that the pH remains exactly at 7. Okay. Next, if I take, so NaCl is done, Na2SO4 is the next one. Na plus will undergo hydration. What will happen to sulfate? Sulfate since is derived from a strong acid, यहाँ भी hydration ही सिर्फ होगा. Again hydration, and this will also undergo hydration because K plus must have come from a strong base KOH. K plus must have come from a strong base KOH and NO3 minus must have come from a strong acid HNO3. So hydration. Hydration. Next, calcium acetate. So acetate comes from a weak acid, acetic acid, and so can I say this cation will undergo hydration, but the anion will undergo hydrolysis. ये anion का hydrolysis यहाँ पे हो जाएगा. Next, cation is coming from a weak बेस NH4OH. सो क्या होना चाहिए उसका? वी शुड हैव ऑब्जर्व्ड हाइड्रोलिसिस फॉर द कैटायन एंड एनायन का सिर्फ और सिर्फ हाइड्रेशन ही होगा, क्योंकि Cl माइनस कहां से आ रहा होगा? HCl से. एंड इन दिस केस क्या लिखेंगे? कैटायन इज कमिंग फ्रॉम अ वीक एसिड, एनायन इज कमिंग फ्रॉम अ cation is coming from a weak base, anion is coming from a weak acid, therefore hydrolysis दोनों की होगी. हाइड्रोलिसिस इसकी भी होगी, हाइड्रोलिसिस इसकी भी होगी. अब अगर मैंने pH लिखना है सभी की केस में, सो जहां पे सिर्फ और सिर्फ हाइड्रेशन हो रहा है कैटायन एज वेल एज एनायन का, वहां पे pH इनवेरिएबली 7 ही रहने वाला है. ओके, इसका 7 रहेगा pH, इसका भी 7, it will be 7, it will be 7. In the fifth case, if cation is undergoing hydration but the anion is undergoing hydrolysis, हमेशा याद रखो अगर कोई anion hydrolysis करता है, मैं यहाँ पे लिख देता हूँ, अगर कोई anion hydrolysis करता है then it will always produce OH minus as a result of charge balance. And if a cation does that, it will always produce a cation. तो आप समझने की कोशिश करो, वाटर के अंदर कैटायन क्या प्रोड्यूस हो सकता है वाटर से रिएक्शन करने के बाद? H प्लस. वाटर के साथ रिएक्शन करने के बाद एनायन क्या प्रोड्यूस हो सकता है? OH माइनस. सो आई विल बी गेटिंग POH. अंडरस्टूड? अब किसने हाइड्रोलिसिस किया? एनायन ने. Anion is producing OH minus. So our pH of the solution will be more than 7. यहां पे कौन हाइड्रोलिसिस कर रहा है? कैटायन. सो हमारा pH क्या होना चाहिए सॉल्यूशन का? pH should be less than 7. एंड यहां पे दोनों हाइड्रोलिसिस कर रहे हैं. सो ओवर हियर pH डिपेंड्स ऑन pKa एंड pKb. जो ये एसिड प्रोड्यूस, कैटायन हाइड्रोलाइज करके क्या प्रोड्यूस करता है? बेस. एंड एनायन हाइड्रोलिसिस होके एसिड प्रोड्यूस करते हैं. सो ये दिस एसिड एंड दिस बेस pKa values are important to identify the pH over here in the last case. Okay, I hope this is clear. आपको समझ में, आप कोई सॉल्ट देख के अब आगे से अब घबराओगे नहीं. ठीक है? नाउ मैं आपको एक सिंपल आइडिया दे देता हूं कि हमारे पास कितने तरीके के सॉल्ट्स हम लोग यूटिलाइज करते हैं इसको एक्सप्लेन करने के लिए. सो वी यूज सॉल्ट ऑफ स्ट्रॉन्ग एसिड, salt of strong acid and strong base. अब आपको इसकी जरूरत नहीं है, आप डायरेक्टली बता सकते हो कि आप इसमें pH क्या होगा. इसका pH हो जाएगा 7, because I have told you कि अगर strong acid और strong base से if a cation and anion is being derived, then both of them will only undergo hydration and they will not undergo hydrolysis. Strong acid and weak base. Example is NH4Cl. यहाँ पे हमारे पास pH should be less than 7. अब ये मत कभी बोलना कि because NH4Cl is produced in the medium and Cl minus will produce HCl on reaction with water, इसीलिए pH 7 हो जा रहा है. ऐसा pH 7 से कम हो जा रहा है. It is not like that. It will always be because of ammonium's reaction with water. Cl minus तो reaction भी नहीं करेगा. Okay? इसकी हाइड्रेशन होगी, सॉरी इसकी हाइड्रोलिसिस होगी. ओके, नेक्स्ट, वीक एसिड प्लस strong base, CH3COO and A. who will get hydrolyzed? मैं highlight कर देता हूँ who will get hydrolyzed. So in over here NH4 plus will get hydrolyzed, over here CH3COO minus will get hydrolyzed, and over here the pH of the solution will be more than 7. Next, weak base plus weak acid CH3COO NH4 that will do. Okay, so pH depends on pKa, pKb. ठीक है? Now let's take a very simple situation. अगर मैं फर्स्ट वाले सिचुएशन को हटा दूंगा तो pH 7 ही है, लेकिन अगर मैंने B वाले सिचुएशन को ले लिया, NH4Cl वाले सिचुएशन को लिया, then I can write this as NH4 plus. So this is just one scenario that I am taking, and other scenarios के लिए मैं directly expression लिख दे सकता हूँ. So NH4OH plus H plus. So if the concentration of this is C, this will be initially 0 and 0. This will hydrolyze to an extent H. This will become CH, this will be CH. H is the degree of hydrolysis. So the hydrolysis constant will be written as CH square, which will be equal to concentration of NH4OH times H plus divided by NH4 plus times H2O. अब क्या कीजिए कि you multiply, if you are seeing numerator has H plus, then you multiply with OH minus and divide by OH minus. Ultimately, you will be able to break down this equation into two parts. You will be getting KH as equal to CH square which will be equal to KW upon KB. You will get this expression. Okay, and if I were to write H plus ion concentration, H plus ion concentration will be equal to C times H. So can I say from here H is equal to root over KW upon KB times C? Okay, so I'll write C times root over KW upon KB times C, which will give me root over KW times C upon KB. Now if you take negative log on both sides, we ultimately end up getting this expression. If I take negative log of H plus, I'll get pH. I'll get 1 by 2 pKw minus pKb minus log C. इसको फाइनली सिंप्लीफाई करके आप ये लिख सकते हो 7 माइनस पी के बी अपॉन 2 minus log C upon 2, and this gives your final expression for pH of the solution. Okay, this gives your final expression for the pH of the solution. Apart from that, this part is also asked at times. Also this can be asked. So ये सारी चीजें फाइनल पीएच निकालने के प्रोसेस में वी एंड अप डिराइविंग. ओके, विथ दिस आइडिया ओवर हियर कैन आई से दैट आवर एक्सप्रेशंस विल बी लाइक दीज. So I've already taken salt of a strong acid, a strong base is 7, so I do not need to write any expression for this. If it is a salt of a strong acid and strong base, pH will exactly be 7 at equivalence point. For strong acid and weak base like NH4Cl, our expressions will be pH, which is 7 minus pKb upon 2 minus log C upon 2. If it is a weak acid plus a strong base like CH3COO and A, in such a case the pH will be written as 7. Okay, 7 plus pKb upon 2 प्लस log C अपॉन 2. यहाँ पे सारे जो पार्ट्स हैं दे pKa, I'm very sorry for this, pKa upon 2 plus log C upon 2. Every part is being added because the pH has to be more, and acetate produces acetic acid for which I will write Ka, and therefore our expression will be like this. Third case हमारे पास हो जाएगा weak acid, weak base, CH3COO NH4. Your pH will depend only on the Ka and Kb value, or pK, pKb values. It will not depend on the concentration. So the role of pKa was, as we observed in equation 2, the pK क्या कर रहा है कि pH को increase कर रहा है, Kb क्या कर रहा है, pH को decrease कर रहा है. So I will write this thing as plus pKa upon 2 minus pKb upon 2. So this is a very simple way to remember these relationships. Okay, these relationships do get asked, in sense they will not ask you to write these relationships or derive these relationships, but they will give you questions where you will be solving things using these relationships. Okay, now it is imperative to know that there are some other types of salts which can also be created in this process. What are the other types of salts which are also created? So that, if this part is done, let's move on to this one, salt hydrolysis of anions of a polyprotic acid. यहाँ पे एक major challenge आता है सभी, for a lot of students. If it is a polyprotic acid मैं लिख देता हूँ H3PO4 के जैसा. तो H3PO4 जो होते हैं, it produces H plus and H2PO4 minus. अब H2PO4 minus would also dissociate to give H plus PO4 3 minus. It will give HPO4 2 minus, and HPO4 2 minus would give H plus PO4 3 minus. So can I say that in this sequence H3PO4 H3PO4 ends up producing H2PO4 minus, HPO4 2 minus, and it also produces PO4 3 minus. Now it is important to know that इस पूरे sequence में, in this whole sequence, H3PO4 is the acid because it is only producing H plus. This is not taking up H plus, and PO4 3 minus is a base. ये दोनों जो species है ना, these two species are amphiprotic. Why they are amphiprotic? Because they can take up H plus and they can also give out H plus. देखो, H2PO4 minus if takes up H plus, it becomes H3PO4. If it gives out H plus, it becomes HPO4 2 minus. Same goes with HPO4 2 minus. HPO4 2 minus if gives out H plus, it will form PO4 3 minus. It takes up H plus, it will form H2PO4 minus. So you have to understand very very carefully कि आप pH कैसे कैलकुलेट करोगे अगर ये बन रहा है, ये बन रहा है और ये बन रहा है. So there are two cases that will arise. If the anion is amphiprotic, then in such a situation pH will be calculated as the pKa through which it is formed plus pKa through which it is dissociated upon 2. Okay, we're not going to get into the derivation of this. What does this mean? So let's say this is Ka1, Ka2, Ka3. Let's say they have given a salt like Na2HPO4. अब बताओ इस सॉल्यूशन का pH क्या है? इसमें कुछ भी अमाउंट डाल दिया गया है. Okay, concentration, it's not concentration dependent. You just have to identify what is the pH of the solution. So can I say HPO4 2 minus is produced in this equilibrium and it is utilized in this equilibrium? Can I say that? HPO4 2 minus is produced as a result of this equilibrium and it is being utilized as a result of this equilibrium. Okay. इस equilibrium के लिए हम क्या लिखते हैं? Ka2 और इसके लिए क्या लिखेंगे? Ka3, क्योंकि आप देख लीजिए Ka1 is production of H2PO4 minus, Ka2 is production of HPO4 2 minus, Ka3 is production of PO4 3 minus. So if I were given, let's say 0.1 moles of Na2HPO4, then the pH of the solution will utilize pKa formation. आप क्या लोगे? pKa2 of H3PO4 and pKa dissociation will be taken as pKa3 of H3PO4 and इनका average will be the pH of the solution. Another case that arises if anion is not amphiprotic. Okay, so we are anions of polyprotic acid. Polyprotic acid can produce an anion which is not amphiprotic, and this is this one. This is phosphate. In such a case, the pH will be calculated as 7 plus pKa. That pKa which produces this. So in this case, pKa 3 upon 2 plus log C upon 2. This would be for Na3PO4. बट अगर मान लो कि आपके पास दे दिया गया Na2CO3 के लिए निकालने के लिए, तब आप क्या लोगे? 7 प्लस pKa2 ऑफ H2CO3 प्लस log C अपॉन 2. अंडरस्टूड? ये pK3 हमेशा नहीं होगा. आई वुड रादर राइट just a moment, why it isn't? Okay, it will not be pKa of formation, आप समझ लो. Okay, whatever is pKa is forming this, you will take that pKa. Understood? बस ये आपको दो इक्वेशंस याद रखने हैं. Okay, so just summarizing this over here, if it is an anion which is amphiprotic, then you will write pH as equal to pKa of formation plus pKa of dissociation upon 2. And if the anion isn't amphiprotic, then you will write pH as equal to 7 plus pKa formation upon 2 plus log C upon 2. But ये जो दो equations हैं, these two equations will be used only if these anions are from polyprotic acid. समझ में आया? Only if these anions are from polyprotic acid, then only you will use this expression. Okay? Let's take a question. A 1 liter solution contains 1 mole of Na2CO3 and 1 mole of H2CO3. What would be the pH of the solution if pKa of H2CO3 is 6.3 and pK1 is 6.3 and pK2 is 10.3. Now, इस क्वेश्चन को जैसे ही लोग देखते हैं, lot of people start thinking कि क्या होगा, बफर बनेगा, salt hydrolysis होगा. सबसे अच्छा तरीका ये है कि you first write कि what are the species which are given. So have been given H2CO3 and आपको दिया गया है Na2CO3. अब एक बात बताओ, H2CO3 is when dissociates in water, it produces HCO3 minus, and HCO3 minus produces H plus CO3 2 minus. The point is, medium has a question has given you this and this. Tell me something. If they are they related to each other as conjugate acid-base pair? The answer is no. They are not related to each other as conjugate acid-base pair. If they are not related to each other as conjugate acid-base pair, then what will happen is always a reaction. This is a acid and this is a base. तो इनके बीच में reaction होगा बेटा. Reaction कैसे करोगे? H2CO3 इस second equation को reverse कर देना है. You reverse this and there you have your result. Understood? So you have taken 1 mole of this and 1 mole of this. Okay, 1 mole of carbonate is being taken and 1 mole of H2CO3 is taken. And this is initially 0. अभी जब reaction होगा तो ये 0 ये बन जाएगा 2. When this becomes 2, it means in the solution only bicarbonate is present. Understood? Only bicarbonate is present. If only bicarbonate is present, bicarbonate क्या है भाई? Amphiprotic. और अब pH कैसे निकालोगे? pH is equal to pKa of formation plus pKa of dissociation upon 2, and क्या pKa formation लिया जाएगा? 6.3 plus 10.3 divided by 2, and that will be 8.3. 8.3 के solution का pH हो जाएगा. Clear? So I hope you have understood a bit about hydrolysis. काफ़ी difficult सी चीज़ लगती है लोगों को, but it is not. It is actually very easy part. And before ending today's session, some important information that people who are interested in going for the topper batch over here in Vedantu, just check this part, which is vdnt.in JEE Topper Notice Board. We keep updating every information over there. And JEE 2023 एस्पिरेंट्स, क्योंकि 2022 चला गया, अभी एक हफ्ते के अंदर JEE एडवांस्ड हो जाएगा. 2023 एस्पिरेंट्स प्लीज चेक दिस स्पेस, एंड 2024 एस्पिरेंट्स प्लीज चेक दिस स्पेस. So that's all for today, guys. This is Saurav Goswami signing off, and we will start with something interesting in the next session. Please do keep watching this space or the Vedantu VOS channel regularly for any kind of a help that you need for your studies, okay, and to make yourself much better than anybody else. So thank you, thanks a lot, guys. Bye bye.